So, good morning for today's lecture. Today we are going to start approximate expression for expectation and variance. Sometimes it is not easy to find exact expectation and variance. In that case, we find approximate value of expectation and variance. Okay. So, we are going to start with a theorem. Okay. So, let x be a random variable with expectation is equal to mu. Okay, and variance of x is equal to sigma square. Suppose that suppose that y is equal to hx. Y is random variable given by this way. Okay, then expectation of y is is approximated to h mu plus h का डबल डेरिवेटिव एट म्यू अपॉन 2 sigma square. Okay, and variance of y is equal to approximated value is given by h dash mu का square sigma square. Okay, let's do its proof. Okay, so note down it, we are going to prove it. Okay, so let's see its proof. We are going to prove it by help of Taylor series expansion. You know Taylor series expansion. What is the Taylor series expansion? Expand the function h in a Taylor series about x is equal to mu. We are going to expand it h in around x is equal to mu, center at mu. Okay, two terms. Okay, so we get what we get, hx is equal to y is equal to h mu plus, okay, x minus mu का प्लस x minus mu का whole square upon factorial 2. Factorial 2 value is 2. Double derivative of mu plus r1. R1 is what here? Remainder term. Remaining thing we are saying that r1. R1 is a remainder term. Okay. Where r1 is a remainder term. Okay. Now discarding, we are going to find approximate value of expectation and variance. Okay. Okay, we are going to find approximate value of expectation and variance. So we are here discarding R1, discarding remainder term R1. We get, we are discarding remainder term. So what we can say, hx is equal to y is approximate to h mu plus x minus mu h dash mu प्लस एक्स माइनस म्यू का होल स्क्वायर अपॉन टू डबल डेरिवेटिव ऑफ एच एट म्यू. Now, now taking expectation both the side. Now taking expectation both the side, what we will get? Taking expectation both the sides, we get what we get. Expectation of y will be equal to approximate value will get because y has approximate value. So expectation value will be approximate as well. So h mu is a constant. Mu value is fixed. H mu is a constant. When we apply expectation, so h mu will be expectation of mu. H mu will be h mu plus h dash mu is also constant. It will come out. And expectation of x minus mu. Again, h double dash mu upon 2 expectation of x minus mu का whole square. Okay. Now tell me, note that what is expectation x minus mu? Can anyone tell me? Huh? What will be the this value? Can you tell me? Open it. X minus constant is there. This will be this, na? And what is the value of this? This is mu. Ex value is mu. And on the constant, expectation is that constant. So this value is actually mu. So what is this? Expectation, expected value of a constant is constant. Mu is a constant. So what will be the expected value of mu? Mu. And what we have considered here, what is ex? We have let it that ex is equal to mu. Mu value we are putting. What is the value of mu? Ex. We are calling mu ex. Now tell me what is x minus mu ka square. Can you tell me what is this value? We have taken it as mu sigma square in the theorem. So tell me what will the value of expectation of y? What is the approximate value of expectation of y? This is h mu. This value is 0. Okay. Plus h double dash mu by 2 sigma square. So it is proof. First part is proof. Okay. Now we are going to prove second part. Next, expand h by Taylor series about x is equal to mu to one term. What we will get? Y is equal to hx is equal to h mu plus x minus mu h dash plus R2, where R2 is a remainder term. Okay, where R2 is a remainder term. Now discarding the remainder term R2, we are discarding remainder term, then what we will get? Y is approximated to H mu plus X minus mu H dash mu. Now taking variance both the sides. Taking variance both the side, what you will get? Taking variance both the sides, we get what we get? Tell me. Variance of y approximated to okay. We are taking variance both the sides. Okay. Then what we will get? This is equal to variance of h mu. Now tell me what we will get. Can anyone tell me? I told that h mu is a constant. H mu is constant, and this is another random variable. I told that if you add a constant in a variance and take the variance, then constant do not affect anything. So what will the variance? This is a constant, na h mu, and this is a random variable. This part is a random variable. So I told that I am writing here variance of c plus x is equal to actually variance of x. We are going to apply this formula here because mu x is a constant. So what will be this? Variance of h dash mu x minus mu. Now we are going to apply another formula. What formula we are going to apply? We are going to apply if c is there, then c square will come out. This formula. So what will be this? Can you tell me? H dash mu का square variance of x minus mu. Okay. Again mu is a constant. Mu is a constant. Then what will again applying this formula? What we will get? Variance of x, and variance of x is nothing but we are letting it mu sigma square. Sigma is a standard, okay, deviation. So what we got actually? This implies variance of y is equal to approximated to h dash mu का square sigma square. Both are proved. Okay. Okay, we are going to generalize this result in case of two-dimensional random variable. Okay. Theorem I am writing. I am not going to prove it. So let x, y be two-dimensional random variable suppose that suppose that expectation of x, I am writing mu x, in base I am writing x, expectation of y I am writing variance of x, I am writing standard deviation of x का square, variance of y, let z is equal to hxy function. Then if x and y are independent, one thing is important here, x and y are independent here. We have expectation of z. What is expectation of z? Expectation of z is approximated by h mu x mu y plus 1 by 2 del 2h del x square sigma x का स्क्वायर प्लस del 2h del y square, second derivative with respect to y, sigma y का square. And what will be the variance of z? Del h upon del x का स्क्वायर सिग्मा x का स्क्वायर प्लस del h del y का स्क्वायर sigma y का square. So these are two formulas. We are not going to prove it, okay? But this have fun. Please note it. This is a generalization. In case of derivative, and you have a function of two variables, partial derivative takes place. Similar kind of generalization, if you observe that. Okay, note it. Now we are going to study Chebyshev inequality. Chebyshev inequality. First, you note that if we know that if we know the probability density function or probability mass function of a random variable okay, x, we can compute ex, expectation, and variance vx, etc. Other things we can also compute. Now my question is converse. Is the converse true? Answer is no. Converse is not true. It means if I know variance and expectation, can I find probability density function or probability mass function? It is not true. Okay. So, and hence, if we cannot calculate probability mass function or probability density function, we cannot find probability as well. Hence, we cannot not compute such as p x minus mu less than c. We cannot compute the value of this. Okay. Now, next is that, but we can give a very useful upper bound or lower bound to such probabilities. Okay, using Chebyshev inequality. So what is Chebyshev inequality? What is Chebyshev inequality? Now we are going to write Chebyshev inequality. What is that? Chebyshev inequality has flowing forms. Okay. So p x minus mu less than greater than c greater than equal to epsilon. Epsilon is a real number. Less than equal to e x minus c का स्क्वायर epsilon square. Okay. This is Chebyshev inequality. This is Chebyshev inequality. This is Chebyshev inequality. If in place of c I will take a mu, what will happen? If I will take c is a constant, I am taking mu in place of c, what we will get? Probability of x minus mu greater than equal to epsilon, that will be, this will be equal to x minus mu का square epsilon square, where c I am taking mu. Now tell me, what is this? What is this? What is, we know that e x minus mu का स्क्वायर, ये क्या होता है? This is variance of x, and variance of x is written by this way. So we can put this value here. So what we are getting? Okay. Now third. Now take epsilon is equal to k sigma. Then what we will get? Probability of x minus mu greater than, if we have continuous random variable, including boundary point will not affect anything. Okay. So this will be sigma square k square sigma square. Sigma square से sigma square cancel out. Okay. So we have C is equal to mu and epsilon is equal to K sigma. Okay, let's see its proof. We are going to prove it. First part. Because if first part is proved, rest two part will come automatically. Now consider the right hand side of 1. What is right hand side of 1? So what is this? I am to take integral of probability density function on the region X on such X which satisfies this condition. X minus C including boundary point or skipping boundary point in case of continuous random variable will not affect anything. Okay. So how we can write this integral? What is the meaning of this? If I say x minus c is greater than epsilon, what is the meaning of this? It has two meanings. This happens if x minus c is greater than epsilon or x minus c is less than minus epsilon. So above thing, if you solve, what you will get? C plus epsilon. And lower thing you will solve, what will get? C plus C minus epsilon. Okay. So you have, what is the range of your x? It means you have the following range. Following range you have minus infinity to, sorry, here this will be less than. Okay. So you have following range minus infinity to c minus epsilon union c plus epsilon to infinity. It means x limit is in this range. So we have to take integral in this range. Okay. So what will be the integral? Minus infinity to c minus epsilon fx dx plus c plus epsilon to infinity fx dx. Okay. Now observe that now x minus c is greater than epsilon if and only if x minus c squaring both the sides. Epsilon square is greater than equal to 1. Okay. So from here, what we get? Because now we are taking, if we take integral over whole integral minus infinity to infinity, what we will have? Fx dx now. So if we take integral, I am taking the integral over this region. Okay. So because its value is greater than equal to 1, if we write here and multiply fx dx, it will happen because यहाँ पे 1 है, यहाँ पे 1 है, and we are multiplying with greater quantity, the integral will increase. Okay. Now we are taking integral over this region. This is subset of minus infinity to infinity. If we take minus infinity to infinity, then what will happen? The integral will increase. Okay, so epsilon square will come out minus infinity to infinity x minus c का square fx dx. Can you tell me what is this? Can you tell me what is this? This is expectation of x minus c का square, and 1 upon epsilon will come as it is. And what is this? This is actually variance. Sorry, not variance, because for variance we need c is equal to mu. So we got this one. So finally what we got, I am writing here. I got p x minus c greater than equal to epsilon is less than 1 upon epsilon square e x minus c का square. So we have proved first part. Other two part will come automatically because by substitution, taking c is equal to mu and then taking c is equal to mu and epsilon is equal to k times sigma. So we are going to do one example. Please note it. Okay, it is noted. Example. Suppose that it is known that the number of items produced in a production line in a factory during a week is a random variable with mean 50 if the variance of a week production is known to be to equal 25. Okay, then what can be said about the probability that this week production will be between 40 and 60. Okay, so I am reading the question again. Suppose that it is known that the number of items produced in a production line in a factory during a week is a random variable with mean. What is the meaning of mean? Mean is expected value is 50. If the variance of week's production is known to be equal 25, it means variance is 25. It means sigma square. It means expectation of x minus mu square. Then what can be said about the probability that this week's production will be between 50 and 60? Okay. Solution. So one thing you observe that I am to calculate this probability. I am to calculate this probability. So what is inside thing? Can you tell me? 40. If I subtract 50 in each term, so what will get? Minus 10. So how I can write it now? Can you tell me? X minus 50 less than equal to 10. Okay, it is clear. It means the meaning of this is what? Okay, meaning is this. Now what is the formula? What is the formula? P x minus C. I know this formula only. That is less than 1 upon epsilon square. Okay. Or now I'm going to change this formula. By second parts formula you take x minus mu variance square epsilon square. This is the in the question it is given that mu is equal to expected value is 50. 50. Variance is given 25. So from here what can you say about this? Mu का वैल्यू रख दिया 50 और एप्सिलॉन की वैल्यू रख दी 10. So tell me what will be this? 25 upon 10 का square. What will be this after solving? 0.25. Okay. So it means is less than 0.25. We know that. We know that P x minus 50 less than 10 plus because x is a continuous random variable and x minus 50 greater than is equal to 1. Now tell me what will be the value of this part. Can you tell me? Huh? This will be equal to greater than equal to this will be 0.75. So this implies probability of 0.75. So this is the answer. Okay. Therefore, the probability that this week's production this week's production will be between 40 and 60 is at least 0.75. Okay. Now we are going to do one important question. It is simple. Please note it up to this. Huh? Oh, yeah, yeah. Yes. Yeah, this. Sorry. This na? It's fine now. We are going to do one more question. This is not theorem actually. This is question. Let variance of x is 0. Okay. Then probability of x is equal to mu is equal to 1. How to show it? Can anyone do it? Can anyone can do it? What is variance of x? Variance of x is given 0. It means sigma square is 0. Now, by Chebyshev inequality, we get what we get. What is Chebyshev inequality? Chebyshev inequality is x minus mu greater than this is less than sigma square upon epsilon square. Now sigma square is 0. Put the value of sigma square. What you will get? Sigma square is value is 0. So 0 upon epsilon square. That is 0. And probability is always a non-negative part function. So what you will get? Probability of x minus mu is 0 for any epsilon greater than 0. It means we have for any epsilon greater than 0 we have this one. So letting epsilon, okay. So what can you say about this one? Probability of x minus mu less than, what can you say about this? What will be this? Because sum of these two parts is actually 1. You have this part 0. So what you have this? This will be 1. This will be equal to 1. Okay. For any epsilon greater than 0. Okay. Now letting epsilon tending to 0, what we get? अगर मैं epsilon को 0 की तरफ टेंस कर दूं, what we have? X minus mu, this will be equal to 0, equal to 1. But this is inside thing always non-negative. So what can you say? So what is the meaning of this? When this will happen? If x is equal to mu is equal to 1. So this is true. Please, you can note down it. So probability that x is equal to mu is actually 1. Okay. So today's lecture up to this. Thank you very much.